So welcome everyone to the first event of the German American Conference of 2021. We are so excited to have you all join us for a panel in AI in medicine. I am Valeria Rabayo, one of the conference organizers this year, and I wanted to give you a brief overview of our event. We will start off with a panel discussion led by our moderator, Dr. Rostalski, and we expect that you will all have many interesting questions yourselves and ask that you post them using the Q&A tool throughout the event. We will transition to audience questions for the last 15 minutes of this event, and we'll do our very best to get to all of them. I will now hand it over to Debbie to give us a brief introduction.
Hello, everyone, again. I'm Debbie Budinsky and one of the organizers of this year's conference. Given the rise of artificial intelligence in medicine, we organized this panel to shed light on what leaders in academia and industry are working on, what challenges, both technical and ethical, lie ahead of us, and how such methods will be received by doctors and patients. Our panel features a range of experts in AI applied to medicine from both sides of the Atlantic and from both industry and academia. The panel will be led by our moderator, Frauke Rostalski. Dr. Rostalski is a professor of law at the University of Cologne and an expert on the legal and ethical implications of digitization. She advises on legislative projects at state and federal level and has been a member of the German Ethics Council since April 2019. I will now turn it over to Dr. Rostalski to introduce our fantastic panel.
Thank you very much, Debbie. Ladies and gentlemen, I'm very grateful for the invitation to this important event. Artificial intelligence in medicine entered into a significant relationship a long time ago. With advances, especially in machine learning, this connection has gained momentum and poses challenges to us as a society, to our ethics and to our law. What our future looks like, we are shaping. We must therefore ask ourselves how much AI is desirable, what are the opportunities that come with it, and do they outweigh the risks of this new technology? I'm very pleased to welcome experts in this field today and to discuss some important questions with them and you, our audience. So let me first of all briefly introduce our panelists. I already see Professor Collin Stultz. Collin is the Minor T. and Robert H. Rubin Professor in Medical Engineering and Science, a Professor of Electrical Engineering and Computer Science, a faculty member in the Harvard-MIT Division of Health Sciences and Technology, a member of the Research Laboratory of Electronics, and an associate member of the Computer Science and Artificial Intelligence Laboratory. He is also a practicing cardiologist at the Massachusetts General Hospital. Collin received his undergraduate degree in mathematics and philosophy from Harvard University, a PhD in biophysics from Harvard University, and a MD from Harvard Medical School. His scientific contributions have spanned multiple fields, including computational chemistry, biophysics, and machine learning for cardiovascular risk stratification. Currently, research in his group is focused on the development of machine learning tools that can guide clinical decision-making. So let me go on with Dr. Lily Peng. Welcome to you. Dr. Peng is a physician scientist and product manager at Google Health. Her team works on applications of deep learning to enable better and more equitable care. Some of her team's recent work includes, for example, detecting breast cancer and lung cancer from screening scans. Her highly influential papers have been published, among others, in Nature and Nature Medicine. She graduated with an MD, PhD in bioengineering from the University of California and a BS in chemical engineering from Stanford. She co-founded Nano Precision Medical, a drug delivery device startup, and was a product manager at Doximity. In recognition of Dr. Peng's contribution, she has been named in Fortune's magazine 40 Under 40 in Health and Wired magazine's list of 20 people who are creating the future. Our next panelist is Jennifer Nelson. Jennifer is US Director of Clinical Software and Solutions at Dentsply Sirona, the world's largest dental technologies and consumable company. She is responsible for driving innovation to develop an integrated ecosystem of connected devices and software leveraging AI at scale to enable aesthetic, functional, and clinical precision of dental treatments. She received an MBA from Babson College Olin School of Business and a bachelor's degree in marketing from Suffolk University. She is also passionate about diversity, equity, and inclusion and leverages her leadership positions at Dentsply Sirona's D&I Council and employer resource groups to influence corporate strategy on DE&I. This year, she was recognized as a 2021 Paradigm for Parity Women on the Rise, acknowledging innovators breaking barriers in corporate leadership and showing the value of gender parity and racial equity in the workforce. Last not least, let me introduce Professor Dr. Felix Nickel. Felix is a board-certified surgeon focusing on robotic-assisted surgical procedures at the Department of General, Visceral, and Transplantational Surgery at the University Hospital Heidelberg. His expertise lies in the fields of AI, machine learning, and augmented reality systems. In these areas of research, he has authored and co-authored numerously highly cited publications in leading scientific journals. He believes in an effective and efficient cooperation of human and artificial intelligence in the operating room that will massively improve patient safety in the long term. So I'm very pleased that the four of you are here today. I'm looking forward to our discussion. Let me start with my first question. The first question I'm going to ask is about the current and future state of AI in medicine. Felix, I would like to ask you, where is AI currently being applied in medicine, in the operating room, primary care, etc.? Could you give us some information about this?
Yes, that is a very good question indeed. I think for real clinical practice, AI has found its way mostly in fields that rely on visual information. This is, for example, in dermatology. There's lots of AI research, but already also clinical use going on. Then pathology is a really huge field where AI is applied in clinical practice, in everyday practice. And of course, radiology. Mm-hmm. This is also already happening in my hospital, and we see this in everyday use. This is very interesting. I think certainly also in cardiology, this is applied more and more, but I think Collin is probably the better person to answer this question. Concerning surgery and other interventional procedures in medicine, AI is currently mostly applied in research, but there's lots of development going on, and this is very interesting. And this is also what I'm fascinated in.
Going to ask about the interplay of academia and the practice. And one of my next questions, maybe Collin, could you add something, or would you like to add something?
Well, I'll just be brief. As Felix mentioned, I want to distinguish between the research space versus the actual people who are healthcare providers and their access to AI. And there's lots of research in very different spaces, but in terms of the implementation, at least on my side of the world, there really isn't a great deal. There are clinical trials that are underway to evaluate the utility of a lot of the methods that you see in the literature and to determine how well they work in clinical practice. But there is a gap between the research advances and what's actually used in practice.
That's interesting. What do you think are the current technological limitations of these applications, Collin?
So I think, having access to an electronic health record used to be a big hindrance, which is not anymore because most healthcare spaces have it. Having access to data sets that are in a format that you can easily plug into models to train and to learn things is I think is one remaining obstacle. The biggest obstacle is, however, developing these models, knowing when they work and when they don't work. And knowing their failure modes, I think, is something that is not adequately addressed both in the research sphere and in the application spaces. And some of that is a technological obstacle, but that's, to be brief, kind of a.
Thank you. Dr. Peng, am I allowed to address you by your first name?
Oh, please. Yes, Lily.
Thank
great.
you very much.
Thank you.
So, Lily, what new applications should we be looking out for?
Oh, yeah. So actually, I wanted to echo a little bit of what Collin just said around actually understanding how these algorithms exist in real life, or sorry, how they perform in real life. And that kind of goes to your questions, which is like, what are the new applications? I think one of the big things about these algorithms is the ability to actually, if you put a lot of these systems, if they're all electronic, if they're interoperable, right, and if their data is coming in real time, the actual new applications is sort of this new time real world performance monitoring, right? So if you have systems that have all these things, one of the things that you get is a report back to see how not just how the AI performs in real time, but also potentially how humans and healthcare systems are performing in a more kind of real time manner. So there are obviously very specific applications, right, that people are building and getting approvals, and there, as Collin mentioned, there are several things that are going through clinical trials. There are actually things, the FDA published a bunch of things that actually have approval that are AI enabled, and those are all very exciting. But I think the thing that is going to change the speed of innovation will be our ability to look at how these devices work with real users.
Mm-hmm. Okay. Jennifer, what do you think? What kind of application should we be looking out for in the future?
Yeah, I think in the future, and I'm speaking particularly for the dental industry, I think there's a tremendous opportunity to make it very patient-centric. I mean, how many of us look forward to our dental appointments? Not a single person could say yes to that. And, really equipping dental professionals with the technology to identify and diagnose oral pathologies very quickly, utilizing digital scan data that we already have prevalent, and being able to generate treatment proposals that make sense to the patient. So I think there are a lot of technologies that are already being implemented in smaller ways, but really looking at it across the spectrum from end to end of that patient journey, from case acceptance all the way to monitoring and following up, and leveraging AI technologies in each one of those steps.
Thank you very much. Lily, what AI technology is the industry specifically working on right now?
So the clarification, is it Google in particular that we're working on, or are you thinking like kind of an industry overall? Because
I think Google would already be very interesting for me.
Okay, yeah, I think there is about overall. First, I'll say overall, there's a lot of efforts going on across all industries, right? So, that's not specific to just healthcare, and it's not specific to just medical technology, med tech companies, right? Pharma companies. Lots of companies are trying to figure out how AI can help their both in the clinic, but also other kind of logistics type of things. But in particular, I think at Google, we've been working on thinking about how AI can really, to Jennifer's point, improve the relationship between patients and their providers. I think a lot of times when we think about AI, we think, it reduces workload for the providers. Well, why do we want to reduce workload for providers, right? Which part of the workload do we want to reduce? Well, it's administrative burden, right? It's the ability to, we'd like to decrease the amount of noise, the amount of like kind of noisy data that you have to look at and be able to surface relevant data to the provider. And the reason for that is so that they can interact with a patient in a clearer way, right? They know what they're looking for. That time, the administrative burden time, can be then actually redistributed towards patient care. And in the same level, a lot of times what AI could do for patients is help with their understanding of whatever is going on with their disease or their health state. And so that when that conversation happens with their clinician, they know which questions to ask, right? They're able to have a conversation that's a little bit more in a more high bandwidth kind of way. So I think that's kind of the interesting things about where Google is spending some effort, is thinking about, okay, well, what are the ways that we can both help patients and their providers like come together in a health journey.
Yeah, so to improve the relationship between the physician and the patient. Jennifer, you agree with this?
Absolutely. I mean, I think nowadays patients tend to end up on the dark side of YouTube researching procedures and web and educating themselves about things because they dread that interaction. They sometimes feel overwhelmed or not fully informed about procedures. So how can we leverage AI technologies to support providers and communicating clearly about treatment options? And even when we start looking at, Lily talked about, the administrative sides of things. I think clinicians go into a practice because they love the human interaction. They love caring for others. How do we take away some of the burden of, managing large data sets and being overwhelmed with making the right clinical decision while caring for that patient? So yeah, I absolutely agree with that for sure.
Collin, what are the fundamental problems we're facing in bringing AI to the clinic, and how do we solve them, or can we solve them?
Well, I was hoping that you were going to tell me how to solve them, but I can tell you what the problems are.
Mm-hmm.
And I think, as we've already alluded to, and as Lily mentioned, about finding failure modes. So models are typically trained on one particular data set, and oftentimes those data sets are derived from a specific hospital. And in computer science, we have this phenomenon called distributional shift. So the patients you want to apply it to can be quite different in ways that are very subtle than the ones that you have trained your model on. So identifying what patients the model is appropriate for or not appropriate for is a significant challenge that I think hinders the ability. There's also things about this also relates to bias, because humans have intrinsic bias. Data sets have bias, and algorithms inherit the biases of their data sets and of their developers. And then lastly, in this issue of trust as well, is this problem about explainability. So, and there's disagreement in this conversation amongst specialists. But if these algorithms are quite complex, it's difficult to understand what they have learned. But yet, still, a clinician who doesn't understand this mysterious prediction or this mysterious output that comes from an algorithm that doesn't speak in a language that they understand. Clinical healthcare providers speak in a language of physiology, the things they learned in medical school, and these algorithms don't speak that language. So having the provider trust that the algorithm is actually doing something that is consistent with their understanding of human disease is also an impediment.
So you would say that there's a lack of trust among the physicians?
There is, and there should be, because these algorithms, the metrics of success are on average. They have an overall accuracy and overall discriminatory ability, but the clinician is concerned with, is that algorithm going to be applicable to the patient in front of me? And if the model doesn't have 100% accuracy, there's a chance it can be incorrect. And these are very high stakes decisions, because it's not like other spheres. It's one thing that differentiates AI in the healthcare sphere from others, because incorrect decisions, especially in my area of expertise, cardiovascular medicine, can be disastrous.
But human beings also make mistakes?
That is true. Human beings also make mistakes. Human beings are not perfect. Nonetheless, let me put it in a different way. Medical schools have been around for a few hundred years, and there's a few hundred years of information that we know that's well validated in many instances. This algorithm has been trained on a small number of patients, and you want to know if the algorithm is going to work in perpetuity, because if it's going to work forever. So you really want it to be consistent with the corpus of body that has been around for 100 years or 200 years. You'd be more certain that it's actually going to be right.
Understand. Felix, do you have any solutions for the problems Collin just described?
I think one big problem that we still have in the entire application of artificial intelligence in healthcare is the amount and quality of data that is accessible to train such algorithms, models, and networks. This is really one of the most difficult parts, to get reliable data that are also generalizable. I think this is a very difficult part.
Okay, it's also only a problem and no solution. Maybe one of the others has a solution for me. Lily, what would you say?
I also don't have solutions, but I absolutely agree with Felix and Collin. They're spot on about these limitations. I will kind of, I will say something. I will say that people are working on it. I don't know that there are solutions just yet. I think that the first part was a recognition that these are, large challenges. And so I've seen, for example, private-public kind of efforts to aggregate data that is, consented in the proper way, but the point is to help, I guess they're called data lakes, or, there's institutes that have try to put some effort into this to gather, usually around certain disease states. So there's, ones for ophthalmology and ones for, cancer and what have you. But to gather all of these together so we could help developers and researchers who otherwise would have difficulty accessing some of this data. The interesting thing about data in healthcare is that, even the most interoperable, like in PACS systems, a lot of times they are stuck in hard drives somewhere. So like the extraction of the retrospective data is hard to do. But I think there's actually also a recognition that we need to start collecting data prospectively, rather than just looking at retrospective data, because the prospective data is where you're able to actually collect additional labels or outcomes or things about patients that you really want to monitor in real life. And that prospective data collection and prospective studies will help answer these generalizability problems. And so I think there is a recognition that prospective studies, whether it is data collection or an interventional studies, this is kind of a requirement, right? Something that you need to do to make sure that things work well in real life. And so I think that's great as we're getting agreement about, what we think is required as we're setting standards of what is required. Standards actually, I think a lot of times standards and regulation, we think, that just slows things down. The truth is that actually makes things safer. It engenders trust, which makes things go faster, right? Imagine, if there were no regulations for traffic and you could just be at a standstill. So I think there's an interplay between the two, and there's a recognition of that. And it's the same thing around transparency, explainability, generalizability. There are folks attempting to figure out how to standardize, how to help developers and researchers communicate in a way that clinicians understand and trust, and that we can build this over this trust and confidence over time. So no solutions, but definitely a recognition of the problem is what I'm seeing, and definitely efforts to address them.
Thank you very much. I think one step might be, as you said, a regulation. Maybe you know that in the European Union, we're actually working on a big regulation for the whole AI sector. So maybe this would be something that's really interesting for the United States as well. I think I'm going to ask my next question to Felix, because you already talked about it a bit at the beginning. How is industry, or how are industry and academia collaborating in the area of AI and medicine? Could you give us some information about this?
This is a question for me?
Yes.
Okay, very interesting. Yeah, I think this is a very important point, and probably one solution to the question that was asked before. I think collaborations will probably give us the opportunity to have incentives for academia and just routine clinical practice to collect data in a way that it can actually be used in a generalizable way for industry and for AI development. I think that is an important point, because when we collect data in everyday clinical practice, of course, we have to do a lot of documentation already, and we are chronically understaffed and overworked. So we will have to find a way to motivate people to do the extra effort of documentation so the data quality is high enough. And I think this is probably within the collaboration of academia and industry.
That's an interesting point. Time is running, so I'm going to go on with the second part of my moderation. I would like to continue with questions of ethics that inevitably arise in the context of application of AI in medicine. Some of them were already in our discussion before. So in my own work, not least as a member of the German Ethics Council, I deal with such questions in depth. And so I'm very curious to hear your perspective on the following questions. So first of all, I would like to ask Lily again, how do we overcome biases in algorithms and limited data sets for underrepresented populations? Is there active research in focus of this area, and what kind of research is this?
There's, this is a very complex and important problem. And I think I'll say that, the research of bias in health is a long-standing problem, right? And so AI is just another kind of way, another lens into this problem. And so there's a lot of things in terms of like a multi-pronged approach here. There's not going to be one solution for all, right? I think the first, one of the biggest ones is I talked a lot about prospective studies, about how prospective studies are really required so that we know that how the algorithm works well in real life. And how do we encourage folks incent and make it actually much easier for folks everywhere to participate in some of these studies. Some of that is awareness in the community. Some of it's just study design. Right? How do you make study sites accessible in communities where there's underrepresentation? And so, how you select sites actually will help a lot. That's kind of one aspect of things, right? You think about, I'm just again describing one example of how we would do this, but the thing is that when you're selecting sites, for example, for a study. Some of the sites that are historically underrepresented would not have a history. This will be the first few clinical trials they'll be running, right? So then you need to actually provide additional support for these sites to get that up. But then over time, these sites will then have the ability to run more studies, right? So there's some upfront investment that is required here. I think part of it is how do you motivate that investment, right? So the first one is regulation. Maybe at a regulatory submission point, it is required. These are things that are required that we want to study, we want to see. You could do that. That would be the stick, so to speak. But there's also carrots, right? What are the carrots that we can offer developers or companies or private public entities, people who are doing research? How do we offer them incentives for doing work in this way as well, right? So I think, again, I'm picking on like one very specific case, in prospective studies, how do we ensure equity there? And you could see that it very quickly balloons into this big thing, like all the things that we can do. Suffice to say, it's we will have to address all of these in very many different points, and have to kind of think about it in terms of like, what are the carrots and sticks that we can apply to kind of push the industry in a way that, in a direction that we'd like.
But I think it's very good to hear, for me at least, that there are several strategies to tackle this problem. So, Jennifer, how do we balance focusing on edge cases versus focusing on more profitable populations?
Well, that's such a great question coming from the industry side, because let's face it, companies want to be profitable. However, I do think that AI actually opens opportunities for us to be more efficient in how we deliver care. And there's a lot of cost savings for that from the industry perspective. When we sort of look at what my company does with providing digital equipment, software, as well as the surgical instrumentation, you look at the entire value chain. And I think a lot of times people focus on, developed countries because it's where you would have the most patient population are able to pay. But when you look at lower income countries where you can tie oral health to overall physical health, there is a motivation for organizations to leverage the technologies that we have to treat those populations. So it has to be intentional. It has to be a part of our strategic mission. We have to have intentional partnerships with organizations, universities, to continue research in these areas. Otherwise, it could certainly be overlooked.
Thank you. So the next question goes to Lily and to Felix. Oh, Felix has a question. Of course, you can pose your question first.
Thank you very much. I actually wanted to add something to what Jennifer said. I think this is probably where the biggest potential of artificial intelligence lies in healthcare, is democratization and globalization of healthcare. This is a very important point.
Thank you. So next question, again to Lily and to Felix. It's a bit a long question. I read it out for you. We use the term automation bias, I think you know it, to describe the psychologically high willingness of people to trust unquestioningly, in a way, in technically generated results, so automation bias. But AI can also make mistakes, as I already said, like human beings. How do we ensure that humans do not unquestioningly accept decision proposals? How do we ensure that man remains aware of his responsibility, which he does not relinquish to technology? Collin already talked about it, and he said there is not so much trust in AI. I'm always afraid that it could be the other way around. So what's your impression, Felix and Lily? So maybe Felix first and then Lily.
Yeah, I'll go first. As enthusiastic as I am about AI in healthcare, as a surgeon, it will take me a long time to really trust AI in the operating room. I will very much like to have decision support and maybe some form of semi-automation, semi-autonomous tasks in the near future, but to really rely on artificial intelligence without really taking decisions myself, this would take a long time for me. And it will have to be proven and validated many times in very well performed clinical trials in comparison to human performance.
But couldn't the support of your decision already be a problem because you trust so much in it and that you don't check it again, recheck the proposal of the AI technology? What do you think?
Yes, of course, and everybody will have to learn to work with this decision support and the reliability and applicability of these decision support systems in the same way as we are used to reading a book as a decision support system. So you have to rely on information. You have to learn how to apply information to your current situation and to your individual patient and your individual surgical situation. So that is something we are used to doing, and this will also happen with artificial intelligence systems.
Okay, Lily, are you more critical or less?
Oh, I think I agree with Felix on this one, for sure. I think we're, in the realm of automation. I actually prefer the term augmented intelligence instead of artificial intelligence or autonomous AI or that sort of thing. Simply because it is more practical. It's more practical in terms of all the things that we talked about in terms of barriers to adoption, trust, et cetera, et cetera. I think we're really at a point where we believe that AI can help with certain tasks, but not with all of them. And for decision making in particular, a human in the loop kind of paradigm seems to be what we're going to do next. It's the same. Even with self-driving cars, right? We don't launch right into self-driving cars. There's a lot of issues with that, right? And so there's certain guidance, alert, different kinds of ways where you can reduce cognitive burden for the user, but not remove any cognition from the user. And so I also think because of this, it's actually really interesting and important for us to think about how the human and the AI systems work together, and the design phase. Mm-hmm. And what I mean by this is that there are whole kind of disciplines called participatory design, where it's not just AI, right? For any new technology, we talk about how that interface with humans need to be designed so that the humans actually understand how, the level of explanation is appropriate for the task at hand, right? So, for example, if I took a picture of a check and it says contrast too low and lighting blah 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 at X%, instead of saying move away from the check, get a darker background, the first set of instructions, while transparent, is not going to be as useful as the second set of explanations, which actually tell the user how to adapt to the system, right? And so those design choices kind of happen in the beginning as you're developing the AI algorithms in parallel, because you have to design what the outputs are, you have to design how you visualize those outputs, and when you show those outputs, right? So all of this actually matters a lot from the beginning. And once you understand how users are going to potentially use this, you can actually start seeing common failure modes that you can then build in monitoring into the system, right? And so you can actually then, over time, as this moves into the real world, have that real world monitoring part as part of the product itself. So yeah, there's, if the question is where do we start? It's really in the design phase that we're thinking about how these two systems, human and AI, work together.
Thank you. Collin, many activities in medicine, you might know, that need to be practiced over and over again to guarantee a high standard of treatment. If we delegate decisions, such as the analysis of X-ray images, to technology, how can we ensure that human beings do not lose their important skills?
Right. Yeah. So I think that's a great question and often comes up, and I think it sets up and this touches on a little bit of what Lily said, a false kind of premise. I don't think the useful role of AI is to replace decision making from healthcare providers, but rather to augment decision making. Mm-hmm. And I think that's what healthcare providers sanction, and moreover, and more importantly, I think that's what patients deserve. So I think it's a non-starter to begin the discussion by saying there's a particular technology that's going to replace a seasoned radiologist, because it's interesting. Radiologists, when they read a chest X-ray, they just don't look at the image and see that there's a one-liner that typically comes along. This is a patient, it's a 90-year-old patient with a history of heart disease who can't breathe. And so then that information is used to guide the interpretation of the X-ray. It's never just the image in and of itself. So I think there's ancillary data that are processed by the human brain, and that the output from whatever algorithm one wants to use has to augment that information that the healthcare provider uses to make their decisions.
Thank you, Jennifer. What do you think about this?
Yeah, I mean, I absolutely agree with Collin. I like to think of it as, AI assisted technology, because, we expect that the clinicians that we work with are utilizing their clinical expertise to validate diagnostics generated by the images that we review. I mean, we generate about 650 million digital scans of patients every single year. And with that amount of data, there's so much responsibility in ensuring that we're processing it correctly, we're analyzing it correctly, and then we're allowing the clinical experts to validate some of this information to the output to be quality, accurate diagnostics and treatment proposals. So I 100% agree. And Felix mentioned this earlier. There is a challenge with data quality. Garbage in, garbage out. So we almost ensure that we are establishing data standardizations that ensure that we are having the best quality data sets for the best quality diagnostics in collaboration with the providers that have to communicate that to their patients.
Thank you very much. So, Felix, you already told us that you're very enthusiastic about using AI in medicine. How receptive are other physicians to AI, and what concerns exist?
Oh, I think we've already talked a lot about the concerns regarding applicability, generalizability, especially applicability to the individual patient. Also, I think especially the so to say older generations of physicians are more reluctant to use digital systems or to rely on artificial intelligence if they cannot understand how decisions or informations or guidance systems work. I think this is a very, very important point, especially when there are high stakes decisions.
Yeah, reluctance with technology is something I know as a lawyer. So thank you very much for me. Unfortunately, time is already up for asking my questions to you. I would like to give our audience the chance now to ask their questions. I'm sure I've forgotten some very interesting points, so I'm very curious to hear the questions of the audience now. There are already some. I read it out for you. Maybe you use the hand to tell me who of you would like to answer. So the first question comes from Mariam Schübel. She asks, the field of AI in medicine is growing very fast, whereas medical students still get most of their knowledge from paper textbooks that may be outdated. How can we make sure both current and future doctors are familiar with these new techniques and use them correctly and responsibly? What do my panelists say? Nobody raises their hand. I'm going to ask some of you. Okay, it's Collin. Thank you.
I think it's a great question. So you have to begin. So a technology that has been developed and well validated in a prospective fashion on relevant patients. How is it that's the sort of thing we're talking about? Healthcare providers in training being familiar with. So that stuff enters into the corpus of medical knowledge like any other discovery. Something special about that. Something that works well, that will help people feel better or live longer, I think becomes part of medical knowledge. The interaction between the technology and healthcare professional, I think the onus is on the developer of the technology to make sure that it is that the information is presented in a way that healthcare professionals can appreciate. Healthcare professionals are concerned with taking care of sick people, and so the onus is on the people who want the technology to be used and embraced to ensure that technology survives the test of that we put any other technology through in these prospective evaluations, that information is presented in a useful way. So those are my thoughts on that.
One of the others too, Lily?
Yeah. So I I think that's actually a really fantastic question because, I was thinking about my medical training and how much time we spent on actually talking about understanding the statistics of lab testing, right? Like what's a pretest probability? What is a post-test probability? What sensitivity? What specificity? These are all kind of, very similar kind of words that we use also in AI, very looking at a new technology. And so, one of the obvious things would be, in a medical school curriculum, as we're kind of, moving into a phase where if we do believe AI is going to be, there'll be AI enabled products in the clinic, then equipping our graduates with the ability to be skeptical and ask good questions and kind of demand good answers from said medical device companies and manufacturers would be probably part of it. Like how to evaluate a test, just like how we evaluate the sensitivity and specificity of any kind of lab test. Like when would we want to order this lab test, use this tool versus not? So I think the question is, how do you match that? How do you match what part of the curriculum gets put into what part of the work gets put into curriculum because it's useful, and which part is like elective and more useful for people who want to specialize in it. So I don't know the answer to that, but it does seem like there should be some space for this kind of in the education journey.
Yeah, I think so too. Thank you. The next question comes from Julia Helmus. She asks,
can I just say just one thing? Oh, I'm so sorry. I will be really, really brief. I just want to distinguish between statistics and machine learning. And I think those same questions that we ask of any test, its sensitivity, its specific value, its the pretest probability are things that we should ask uniformly of all things, not specifically to machine learning. And if the question is about what's specific to machine learning that we should know, I think that's sort of a slightly different question in my mind.
Thank you. So, Julia Helmus, who will ultimately be carrying the cost for these new technologies? The provider, the patient? Is integrated AI in medicine going to continue to lead to increased insurance costs for the individual? That's also an important question from my point of view. Jennifer, what do you think about this?
Well, it's a great question because I think, especially if you look at healthcare globally, there are many opportunities for improvement, especially when it comes to cost for the patient, specifically in the United States. Who carries the cost? I think there is an initial investment to implement new technologies in a practice, a hospital, or anywhere. Whenever you're implementing new technology, there is a cost. However, I alluded to this earlier. There are a lot of efficiencies that practices incur once the technology is implemented. And I do believe that these cost savings are going to trickle down. One example is that we're beginning to look at how do we integrate practice management systems that house patient records and patient data and link that together with imaging units to make it easier administratively for clinicians to match patient records together with images. In addition to that, looking at pre-authorization codes for insurance to ensure that, we're billing correctly for different types of preventative measures that we take on. So that tends to drive up costs due to inefficiencies. So the short answer is, and of course, this is not a final answer, I believe that, there will be tremendous cost savings, which will improve how patients receive care, being better quality without sacrificing the clinical efficacy of treatments.
Thank you. The next question comes from John Lott. He asks, how does privacy interact and or affect the rollout of these new technologies? Would like to ask to answer the question. Privacy question. Maybe it's a typical German question. Felix, would you like to answer? Oh, but
sure,
now,
of course.
First,
I think this is probably as in any other area concerning privacy in medicine and use of data in medical research. So we have to consent patients to allow us to use their data for AI developments as in any other field or kind of research. I think that's probably the same, although if we want to really augment the amount of data that we can use, we will probably have to find some different form of regulation for the use of at least anonymized data.
Mm. In German law, there's a big discussion about the question whether data is your own property or if it belongs to the group of the people. Do the Americans know this discussion too, or are you more relaxed with regard to this? Yeah, Jennifer, you already raised your hand to this question. Would you like to answer?
Yeah, I was just going to add that, you know, we are definitely looking into that when it comes to ensuring that we're, number one, meeting data privacy regulations globally when it comes to this sort of new area, and also just informing folks that, you know, AI and machine learning algorithms are nothing that's new, that we've been using this technology in medicine. I think now that we're sort of taking it to the next level, you know, it raises questions about privacy. So it ultimately, we anonymize everything, but now it's just who owns the data, and I think that's the question, the magic question: who is the owner of the data? I believe patients own their data. Data is not always shared with patients, but I don't know. Maybe some of the clinicians can comment on that, because I'm curious. What do you think about who owns the data?
Also very curious. Collin, what do you say?
No, yeah, without question, a patient owns the data. I just want to say one thing about the privacy issue that's come up as of late. One difference is that, and Jennifer is absolutely, I agree with Jennifer completely that machine learning is not anything new, but the complex models that are being employed today, sometimes it can learn the data. If you have a bad model and it really learns the data very well, there's this concern that the model has sort of memorized all of this private data that has been that is, you know, belongs to patients. They've consented to have it used, and you don't want people to see it. But if you give them a model and it's highly parameterized and it has memorized those data, you've essentially given somebody all of this private data. That is a concern that has come up in the literature recently. So there needs to be some guidance here in terms of in developing these models that does not happen.
Thank you. Only if you're interested, I also think that the data belongs or is owned by the patient, but I also think sometimes that when we stick to this position, then maybe we cannot use all the benefits we could have from machine learning in the field of medicine. So it's some kind of a dilemmatic situation from my point of view. So last question from the audience, it's from Norsha Kader. The question is, what AI applications of medicine are currently the most ethically controversial, and who's the arbiter of these debates? Maybe that's a question for Lily.
You know, I get the controversial one. That's awesome. Yeah, I think the controversies that I've seen stem from a bit of misunderstanding and a bit of Hollywood flair of, you know, describing future states where, you know, AI is making decisions without humans in the loop, you know, that sort of thing. And, you know, I think it stems from a misunderstanding of, well, how far AI and decision support has come. And so that's, I think when we're thinking about controversial things, it's really kind of imagined states. And there are, well, at least that's what really comes into mind in healthcare. I do know that there are certain places where implementation, where trust, transparency, so that are practically more controversial. So, like, for example, there in criminal justice, there are some applications of AI there. In healthcare, it's about kind of how do you prioritize and proportion care based on algorithm, right? How do you distribute certain resources based on algorithms? And much of this has to do with, you know, explainability, transparency, and the ability for people to understand that kind of decision making. So that's kind of where the practical controversies come about. I think the visual images of like what things look like in a dystopian future also kind of stokes a lot of fears. But I think that's a little bit too, it distracts from the real problems that we see already in the implementation. And so it's like, for us, it's a little bit thinking more about, okay, well, what are the actual implementations right now that is causing a bit of issues, or actually a lot of issues in terms of fairness and transparency.
Thank you very much. There's an application we're talking about in the German Ethics Council. Maybe you know that it's about artificial intelligence replacing the conversation with a psychologist. From my point of view, that's highly controversial. But time is already up. I think I could go on talking with you the whole night. For me, it's the night. So for me, the last hour was very interesting and enriching. Thanks to our panelists for answering our questions and for sharing your knowledge and your perspective with us. Thanks to the audience also for your contributions. I say goodbye and pass to Samuel. Thank you very much.
Hi everyone, I'm Samuel and I'm one of the organizers of this year's conference. Okay, wow, what a dynamic and energetic panel discussion and Q&A session. So many thanks to everyone who took part. So obviously, AI has a lot to offer when it comes to the medical domain. I'm sure you'd find this of interest just as I did. The wave of innovation driven by AI is not only transforming clinical decision-making, patient monitoring and surgical support, but fundamentally changing the approach of healthcare for populations. As the amount of data sets available within patient electronic health records continues to increase and the field of AI continues to evolve, a future where high-performance, data-driven algorithms play a significant role in the medical field seems increasingly possible. The future of medical practice, where a patient could see a computer mesh before seeing a doctor or physician, might be sooner than anticipated. However, today, the jobs AI algorithms can perfectly master mainly tasks that still require some human intelligence to complete, such as pattern and speech recognition, image analysis, and decision-making. AI algorithms are great for automating arduous tasks, yet they can outperform humans in the tasks they are trained to do. That means that the synergy of man and machine is already potent and will be of tremendous potential and increasing value for years, decades, and centuries to come. And because of this great potential of AI, it is essential to research how to reap its benefits while avoiding potential pitfalls. A human being is presumably still the best living machine that can be trained and tuned in clinical practice, and more importantly, empathy and patient-focused care and contact. Despite all the technical progress and digitalization, it is essential not to neglect this human and personal level of interaction. And for the complete success of the therapy, goodwill and caring compassion may remain crucial, at least until AI is trained well enough to mime facial expressions and emotions. That's why the most significant challenge to AI in healthcare and medicine is not whether the technologists will be capable enough to be handy or productive, but rather ensuring their adoption in daily clinical practice. With this in mind, I would like to end the AI medicine event of this year's German American Conference with a quote from Stephen Hawking. I believe that we can create AI for the good of the world and that AI can work in harmony with us. We need to be aware of the potential and risks, identify them, and employ the best possible practice and management of artificial intelligence. Now, I'd like to take this occurrence to appreciate the entire speaker lineup and the audience for representing their valuable views. So I would like to thank all the wonderful people who spoke here, especially Dr. Lily Peng as the product manager at Google Health, Professor Collin Stultz from the MIT and MGH, Assistant Professor Dr. Felix Nickel, a surgeon at the University Hospital Heidelberg, Jennifer Nelson, US Director of Clinical Software and Solution at Dentsply Sirona, and of course, Professor Dr. Frauke Rostalski, legal expert and our fantastic moderator of today's event. We've been fortunate to have worldwide renowned speakers, both from industry and academia. Thus, I must remark a proficient sense of gratefulness to you for sharing with us some of the most refined ideas, insights, and approaches in the field of AI. So, of course, I am also very thankful to the audience for listening and attending the AI in Medicine event. Following the pandemic developments, this event was designed as a virtual meeting. Nonetheless, we sincerely hope to welcome you as our guest and audience in real life at Harvard Kennedy School next year. Finally, I would like to invite all of you to the motivational keynote by futurist Gerd Leonhard. After a approximately 15-minute break, he will give insight on why the future is better than we actually think. So thank you everyone, and have a great day and weekend ahead.